Hi, welcome to Raw Math. Today I'm doing a series of videos on radical functions. In this video, I want to find the domain and range of each of these two functions. Okay, so the first thing we need to determine is if it's an odd or an even root. This is an 11, which means it's odd, which means the graph is going to either look like this or like this, which means there are no restrictions on the domain and range. We can see each of these graphs go forever left and right, all real for the domain, and forever up and down, all real for the range. Now, you are welcome to do interval notation, double bar R, or the words all real. All of them mean the same thing. The second one, though, does not have an odd root. It has an even root. It's a square root, which means there are lots of restrictions. To figure out the domain of an even rooted radical, you take whatever's under the radical, the negative 2x plus 30, and that has to be greater than or equal to 0. You can take a square root of 0 or anything positive, but you cannot take a square root of anything negative. All right, so I'm going to bring this 30 over. So I have 2x is greater than or equal to negative 30. When you divide by a negative, you need to flip the inequality over, so x is less than or equal to 15, and that's going to be my domain. Now I'm going to leave it as an inequality. You could do interval notation like negative infinity to 15. You could do a lot of different ways. I just think as long as we're solving it this way, it's really easy to leave it that way. The range is pretty easy to find because the range is based on the endpoints, the bookends of the graph. Because this is a negative 7, we know that the graph goes to negative infinity. There's nothing added out here. We could put a plus 0. We don't need it, but we could, which means the range goes down to negative infinity, and its starting point is 0. So negative infinity to 0. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.